Taking off-the-shelf AI models and integrating them with messy, private company data is the most lucrative challenge in tech right now. High-value enterprise work requires moving past basic prompting and building a production-grade Retrieval-Augmented Generation system, a tool designed to bridge the gap between static models and internal databases. Today, we integrate an AI model, hook it directly to a database, prove it with an eval harness, and deploy it to the cloud. To follow along, you need Python or TypeScript, an active OpenAI or Anthropic API key, a cloud account, and a messy dataset. Completing this rigorous build gives you the exact portfolio project hiring managers look for when recruiting highly paid forward-deployed engineers. Step 1 is setting up a real Postgres database. We are going to load it with an unformatted, vertical-specific dataset, like a spreadsheet of healthcare wait times. Resist the urge to perfectly clean this data. Navigating the ugly 80% of legacy data pipelines is a core part of the job, and your system needs to be tested against that reality. Next, we write the Python or TypeScript logic to authenticate and connect to your chosen large language model API. When you do this, you must pass your API key as an environment variable. Hard-coding keys directly into a script is a security risk that will immediately disqualify you in an enterprise environment. Run a quick ping test in your terminal. If the model responds, your connection is solid. Securing the connection and using unpolished data ensures the system is built to handle the actual edge cases found in enterprise infrastructure. This blueprint shows our central retrieval logic. When a user asks a question, the query hits our router and triggers a targeted search directly against the Postgres database. The database then extracts specific, relevant facts from your messy dataset to use as context. This combined package of the original prompt and the internal context flows into the large language model API, allowing it to generate a highly informed answer. You also need to build in logic to handle external API timeouts and missing data gracefully, ensuring the system remains stable when it encounters an edge case. Forcing the AI to reference specific internal facts before generating a response prevents hallucinations and makes the tool enterprise-ready. Now we move to evaluations, or evals. You cannot rely on manually eyeballing AI outputs for quality control. This chart displays a quantitative pass-fail matrix. We create an eval script that passes 10 test questions through the system, systematically measuring the AI's accuracy against a fixed baseline of truth in the database. Providing these hard, quantitative eval numbers is heavily weighted by hiring managers in top-tier interviews. Next is deployment. A local script works on your machine, but it must be containerized to function in a production cloud environment. Open your terminal and execute the commands to properly package your application. Finally, push this Docker container to AWS or GCP to generate a live, publicly accessible URL. Deploying to a live cloud IP demonstrates that you can move a project from a local prototype to an accessible, containerized application. Let's run a final, complex test query on our live cloud application to verify it successfully relies entirely on our internal Postgres dataset. The last technical step is documentation. Write a scoping document that details the end-to-end loop, explaining exactly what broke during the build and how you fixed it. Explicitly documenting these technical trade-offs demonstrates product judgment, which is the exact skill that separates a standard coder from a forward-deployed engineer. Take this concrete portfolio project and present it directly to hiring managers. Focusing on the complex integration work behind these systems provides the technical evidence required to stand out in the current AI job market.